Hello, I welcome you all to your own channel MSK Learning. Now in this video we will see the higher order differential equation. So higher order differential equation is nothing but that is double differentiation, triple differentiation, so on so, right? So like d square y by dx square, d cube y by dx cube, these are the higher order differential equation. Or you can say d to the power n of y by dx to the power of n, that is where n is not equal to means greater than 1, right? So such differential equation we call it as a higher order differential equation. So we can say that an equation of the form d to the power of n y by dx to the power of n plus p1 of x, right, into d to the power of n minus 1 by dx to the power n minus 1 plus p2 of x into d to the power of n minus 2 by dx to the power of n minus 2 plus so on so plus pn of x into y is equal to q of x, right, where p1x, p2x, so on so pnx and qx are continuous and real valued function. So we can say where p1x, p2x, so on so pnx, right, and q of x are real and continuous function, right, a real and continuous function, okay, is called linear differential equation of order on n. So is called linear differential equation of order n, right? So any equation in the form of d to the power n y by dx to the power n plus p1x to the power this plus p2x d to the power n minus 2 dx to the power n plus so on so p1 of x y is equal to qx, it is in the form that we call it as a differential equation of order n. If n is equal to 2, so we can say that d square y by dx x square, right, plus p1x d to the power x by dy by dx, right now. So that equation we call it as a second order differential equation. If n is 3, so it is d cube by y by dx cube, right, plus p1x d square y by dx square plus p2x dy by dx, that is the third order differential equation, and so on so, right? So this equation linear differential equation with constant coefficient. So this is linear differential equation. Now we can say the linear differential equation with constant coefficient, right? LDE means linear differential equation, right? So an equation in the form of, so you can say further, an equation of the form what, that is in this format, that d to the power of n y by dx to the power of n plus p1 d to the power n minus 1 y by dx to the power of n minus 1 plus p2 d to the power n minus 2 y by dx to the power n minus 2, right, plus so on so plus pn of y is equal to q of x, right, is equal to q of x, right? So where p1, p2, pn are real constant and q of x is a continuous function of x, is called an ordinary differential equation of order n with constant coefficient, right? So here where p1, p2, so on so pn are constant, right, and q of x is a continuous function of x, is a continuous function of x, right? Is a continuous function of x, right? Is called linear differential equation of order n with constant coefficient, right? So now if you have it, so there are the two theorem we have to see, right? That is means you have to find out the general solution of the n differential equation of order n, right? So there are the y1 and y2 are the two solution of the equations, right? So we will see here that you can say there is a theorem 1, right? So what is the theorem 1? That let, or you can say if y1 and y2 are two yes, if y1 and y2 are two solution of the equation right, of d to the power n y by dx to the power n plus p1 d to the power n minus 1 by dx to the power n minus 1 plus p2 d to the power n minus 2 by dx to the power n minus 2, right, plus so on so plus pn of y is equal to q of x, right? So its equation, its solution is what? Y is equal to c1 y1 plus c2 y2 is the solution of the above equation, right? Is the solution of the given equation, right? Of the given equation. All right. Now then if you have a equation, let's say y is equal to v, there are the two equation we have, like let's say that with a constant coefficient, right? If equation is given, this is the first case right now. If the equation is given in this format, and then the general solution of a differential equation of this order contains an arbitrary constant, right? So then we have a solution is what? That y is equal to cf plus pi, right? Where cf is nothing but the complementary function and pi is the particular integral. Cf is the complementary function, right? And pi is the particular integral, right? Particular integral. Okay, so that we can say this is how we will calculate. Now, so that higher order differential equation is given in the operator d, right? So you must know that operator of d, right? So this is operator d. This is just a basic. Let us that we can say you have a differential equation d by dx, d square by dx square, d cube by dx cube, so on so d to the power n by just dx to the power of n, right? So this you can write, that is what? That you can say d by dx is nothing but the d, right? So this is, you can say d, right? d square by dx square is nothing but the d square, d cube by dx cube is nothing but d cube, and so on so d to the power n by dx to the power n we can write d to the power of n, right? So these are the d is the operator of this differential, right? So similarly, if you have a equation is given like that, that is dy by dx. So what is the operator for that? That is operator is nothing but dy, right? Similarly, you have a d square y by dx square. So its operator is d square y, right? And if it is the d to the power n y by dx to the power n, okay now. So if you have a d to the power of y by dx to the power of n, so this is what? D to the power n of y. So these are the operator you can remember, right? So that differential equation of order n, or you can say whatever the equation we have seen at the starting, that d to the power of ny by dx to the power n plus p1 x d to the power n minus 1 plus p1 p2 of x d to the power n minus 2 by dx to the power n minus 2. So that equation can be written in the format of, that is d to the power of n plus p1 d to the power n minus 1 plus p2 d to the power of n minus 2 plus so on, so, right, plus p to the power of n, is it or not, into y is equal to, you have a q of x. Alright, so this is what you can write down the differential equation in the form of operator, right? So these are the basics, that based on that we will solve some problems, right? So that you have to find out whatever the differential equation is given, we need to format that auxiliary equation, and then from that auxiliary equation we will find out the root, and then we can generate the solution. So we'll do the problem in the next class. Thank you.